Okay. Hello, hello, hello. I don't see anything. Is there music? I hear my voice, that's great. I think the stream is online. Okay, let me download the new version before we start. Okay, so friends, ladies and gentlemen, we are still on day 2, and I closed the chat. I'm stupid. Let me reopen the chat. Where do I find the chat? Here. Hello. Okay, so we are back and we are currently on day 2 of our platformer journey. And I split up a little bit the different ideas that we want to achieve. So let me quickly open everything, what we did so far. So we have the basic project setup. We have the integration with Tiled for the map. We have some very basic implementation for game events that we can dispatch and some listeners that can register and then listen to certain events. We have a profiler in place to monitor a little bit our drawing performance with OpenGL, so how many flushes and draw calls we have per frame. We already spawned some collision objects for the tiled map for the ground layer, or actually for all layers which would have some collision information. And we optimized a little bit and used already a tiled map renderer. And today, which was the second part for day 2, I want to create now or follow a little bit my idea of having a separate map which contains the collision information or the box 2D body information of the different shapes. And I want to do that with tiled as well. So there I want to use a tile set, which is a collection of images, I think it's called, where we put in, for example, our player. That is the one that we will start with today. Draw in there some shapes, and out of that, I want to create then the fixtures and the bodies for box 2D. So that is what we want to do today. And also, ideally, get some very basic input handling to move the player around. So push him to the left and right, and see that that would work in Fury as well. For day 3, I updated here a little bit. So there we will optimize then the controlling of the player, that it feels a little bit, or it should actually feel a lot better from control point of view. So when we move and jump, that this gets a lot better than hopefully then on the first or at the end of day 2. It's in reality day 3, but we don't work a full day on these things. It's, I think so far it was between 2 and 3 hours per day. That's what it is. Also on day 3, I want to add then some GitHub action stuff. So some optimization to automatically compile and test the code, because I want to write some tests with the player controls to make sure that he moves a fixed distance over a certain period of time, or also jumps a certain height with a given time, so that is constant and not random. That would be very important. And later on, if we might change or add some new things to that logic, we don't want to break it. So that's why I want to add here some automatic testing. And the last thing, then I stop. So is day 4. There I want to implement then some double jump functionality. So we will add the pineapple fruit, for example. We will need some collision handling. We need to spawn those game objects, and we have this context listener in the physics system then. And also a dash feature. So when we pick up an apple, that the player then very fast dashes in the direction where he's currently facing. That could potentially be a problem. Dashing in the direction where he's facing, because maybe it's possible to somehow pick up an apple and you look at the opposite direction. So maybe we need to dash in the direction between the player and the apple. So we need to calculate the angle and dash him in that direction. That's maybe more future-proof. And yeah, that's it. So day 5 will be then some enemies implementation. Day 6, I want to add a shader, which I worked already with shader, but I never did that specific shader. So I want that when the player takes damage, that he is blinking in a white color or red color, whatever looks better. That is what I want to try here. Day 7 is then some music and sound effects for jumping and so on, which gives then a more or a better feeling to our game. Day 8 will then be the creation of 3 different real maps, and also some map transitions, so that we leave a map and then load the new map and so on, so that we can move from map to map. So we need something like that. Day 9 will be then some user interface stuff, like displaying the player hit points. Also, when you enter a map, maybe at the top, we will show the name of the map. I don't know, the town map or the cliff map or whatever, or the boss area, so that you see that as well. So some small things with user interface. And after that, so day 10 and onwards, let's see if we still have time. Then we want to implement a boss fight, so some AI stuff, a safe load system. And that is what someone mentioned in the last stream. So this AI pathfinding of GDX, that maybe we can find a way with that functionality that is there to move then the player or a ghost or whatever from the start of the map to the end. And it should then still consider all the collisions and everything that we have, so that it doesn't move through walls. It should move over the walls. So something like that we see how that would work. Good. But that's enough for how I ordered my ideas here a little bit. What I did and what I didn't find out last time is I looked up in Tiled how we can use the collision editor and draw the collision tiles more accurately, because last time that was just some free drawing. And I saw on the internet that there should be an option under view. The problem is it was in English, and I don't know why Tiled for me is in German and how I can switch it to English. I have no idea. But under view, there should be something like snapping option. Einrasten, I think it is. And there we can say magnetic, more granular magnetic grid, and pixel on the pixel. So I think we want auf ganze Pixel einrasten, so snap on pixels, and hopefully that allows now, yeah, perfectly. So now it really jumps pixel by pixel. That is what I wanted the last time. And now we can, let me quickly fix the collision shapes from last time. I think it was just 3 of them, if I remember correctly. So that should be fairly simple to fix. So I just move all the edges a little bit up and down to really make sure that we are pixel perfect with the collision shapes. And the last one is this one. So there maybe also we go one more inside like we did it on the left side. Then like this and like this. Okay, so that is already fixed. And now the more interesting part is that we want to spawn a player. And for that, let's go to our original assets with this pixel adventure stuff. And there should be under main characters most likely. What do we choose as a main character? We can use this masked guy here, or a frog, a ninja frog. Might be funny to use that one as the main player. Then we have a pink man, Jesse Pinkman. So, and this blue guy here. I think let's start with the frog. That one looks the most fun. So we go to our raw assets folder. Then maybe in here I create also one additional folder, which I call maybe map. And there I put in the maptere. And then maybe to also group that together. I think that's important. Then later on when we use the texture atlas tool, you see that then in a moment. So here we want to either call it characters or just objects. I would say object. So there we place in all our objects, and one of them is the ninja frog, and we just call it frog, which makes it simpler. So this is a double jump animation. So for now, we start very simple. We just need the idle animation. And unfortunately, that's not frame by frame. So that is one entire sprite sheet with all the idle stuff. Let me quickly check if there's maybe also a version where we have the single images, because that is what we want. Because we want to pack everything together by ourselves and not use the ones which are pre-combined. But it doesn't seem like it that is available. No, unfortunately. Unfortunately, no. So what we need to do is the thing that we did the last time. So first of all, I use a little trick which helps then later on in LibGDX to create the animation. So for every animation, we will create a folder. So for example, for idle, we put in here the idle animation. And we need to split that now. And for that, we use image magic, where we hopefully have still the command back here. That's perfect. So here we want to use... how did we call it? We called it idle.png. And what is the size? It's, can I see that here already? Most likely 32 by 32, I would assume. So crop should be 32 by 32. And then we have idle. And there we have that one. So let's see. That should hopefully create the single images. Looks good. It looks like everything is a little bit duplicated. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11. Okay, no. So here he's moving the arms. I don't see a difference between those two. But maybe the artist put that in there, that there is a little pause between the different frames. So that's... yeah, looks a little bit weird to me, but I guess that is the idea, that it's not a fluent motion all the time, so that it's a little bit more natural with some little pauses inside. And yeah, whatever, I think that is already everything that we would need. So my idea now would be that under maps, we create another map, which we call, I think, the size. Yeah, we can resize later on anyway. It doesn't really matter. Also, the size of the tile itself doesn't matter. Since it seems like we have 32 by 32 characters, we will do it like this, but it's not really important, I would say. And for this tiled map, which is currently called umbenannt, we want to save it under, let's call it objects. And in here, I want to have a new tile set. which is a collection of images. So I think Bildersammlung is collection of images. And that one we also call objects. And I don't know, what is in Karte einbetten means it's part of the map and not stored separately. Let's try that out. Let's see if LibGDX can handle that. And my idea would be now, where do I see that? Ah, here. Here I want to somehow add now a graphic to it. How can I do that? Here. Okay, so it opens it up. It has this special name because it's part of a map, so that makes sense to me. And now let's add here a tile. Yeah, whatever. So I think the problem is if I use now the raw assets folder for that, most likely the path to this folder is then referenced inside the map, and our real game at the end will not contain a raw assets folder. So I'm thinking now of creating a separate folder, just that we have a graphic in the map, which is just used again for simplicity to hopefully make something nice together with Tiled, that we can edit our box2D bodies. And yeah, so under graphics, let's try it out here. So there we will have a new folder that we call objects. And there we play the frog, for example. And let's now try that out. So in the assets folder, which is then really available, graphics object, we have the frog. Okay. And my idea now is hopefully, by the way, it was important that the dimension is correct. I just noticed that now, because if we want to draw the collision correctly for the player, it needs to be, of course, one tile, that the entire player is part of one specific tile, because in here we can draw now our shapes that we want. And if it would be smaller, so 16 by 16, for example, then we would have 4 separate tiles for one object, for one character, which is not good. So actually it was a good idea that we chose the correct size. Okay, so what I want to do now is in here, I set for the feet, I want to choose a circle. And is this a circle, or can it also be something? Wow, that's hard for me to aim. How can I? Okay, so something like that. So that would be my idea, that we can use this here as an editor for our collision shape. So what do we think? So that looks a little bit retarded at the moment, but I think it's okay. So the feet most likely should be something like this and cover just the bottom of the player character. Then we want to have that once more for the head. So here we are a little bit bigger. So I think the graphic always, or ideally, the collision shape is a little bit inside of the graphic, because in the real game, when you collide with something from a player point of view, I think it would be a little bit weird. Like in that case, if a wall is here and then the character stops 2 pixels in front of the wall, because there would be already some collision. So that should be most likely a little bit smaller. So maybe something like, yeah, let's go with that. I think that's okay. And in the center there, I actually want to have a rectangle for that. And let's also make that a little bit smaller. why do I have these errors? And before I think I had some other stuff, but whatever. So that would be like this. It can overlap. I think that's not a problem for Box2D if something overlaps. So I think something like that could be, for example, our Box2D body for the player. I think that looks good. So I want to have two shapes. So two circles, one for the feet and one for the head, and then the hitbox in the center. And what is also nice, first of all, that it's extremely hot in my room, and I will take off my shirt soon. And the other thing is, of course, that we could also give here some properties. So for example, if for whatever reason that should be a sensor, or we want to add here some other information that's, I don't know, maybe that this is a hitbox, this is the head and so on, that we could also then work with the property editor in Tiled, use everything that we have here and still read it then inside LibGDX in our own engine. So I think we have a lot of freedom, and if that works out quite well, then we achieve the goal, because drawing or getting a shape like that via code, that would be really tough, I guess, to program. So it's a lot easier to have here this collision editor and use it for our needs. And yeah, I think that's it. So the map itself is not really important. We don't need to do anything with it. We could maybe later on, if we, for example, write a test for it, we could place the different objects in there, because there we already directly see the collision objects, for example. But for now, we don't use it. So we also, I hope that still works if we don't even have a layer. So we try to keep it as small as possible, because it's actually a useless, it's not really useless, but it would be just a one-time thing. So that is the idea and the thing that we will program now. We load this objects map once, most likely when the game is starting up. Then we parse through the tile layer, or through the tile set, like we did it the last time, to get out this information with the collision shapes and so on. And maybe today, just for simplicity, we will store a map. The key is somehow an object ID, so for example, the player, and the value would be most likely the fixtures that we have here. And when we create then a body, then we can simply reference the fixtures here. They get then the correct position because of the body position. And yeah, hopefully, if everything I have in my mind works out well, we will have then a pretty cool interaction with Tiled as an editor and our game engine. So let's go to our code. No, we don't want to update. So let's think how we want to go about that. So currently we have a game screen. That's our only screen where things are happening. But I would most likely do that. So this loading of the different shapes, it should be most likely part of a loading screen, which would be at the beginning, before, maybe even before you enter the main menu, so that it loads up some basic stuff, some resources, so that you have then a fluent playing experience later on. So for now, I like that idea. So we will go with another screen, and we call that loading screen. Loading screen. I don't like the name a lot, but yeah, let's go with loading screen for now. So that's a KTX screen as well. And what do we need? We need for sure our assets, where we have our own class for that. And I think that's it for now. Do we want to load the stuff now in the constructor or in the show method? I would say the show method, because constructor could be, no, it cannot be. It for sure already has the OpenGL context, because the screen gets created just in the create function of the game. So in here we create the screens, and at that point we already have access to the OpenGL context, so that's fine. So theoretically, everything that I do now, we could also do in the constructor, which would be maybe better, because the show method would be called again and again if we switch to that screen, and the constructor is just called once. But I think the loading screen is anyway just a one-time screen. So really, in the end, it doesn't matter. What we need from our assets, we want to get, how did we call that? I think we did it like that. And we had some map asset, I hope. Yes. And instead of test, we also need now an additional one, which we call object. I think we called it like that, right? We even called it object. So sometimes I use plural, sometimes singular, which is not nice, but it is what it is. So we have objects. Then in our loading screen, we want, of course, the objects map. Let's call that tiled map. And now we want to parse, let's call that parse object collision shapes, something like that, where we parse in this tiled map. And now we can reuse some code from last time. And we need one additional thing. So as I mentioned, let's also create that out there. We will have let's make it an enum class, which we call game object. Because object is a restricted word in Kotlin, and I don't want to clash with that or have some troubles with it. And so we keep it here as game object, and we just call it player. So most likely we will have a component which also has some basic information about an entity, and it also will contain this game object ID. And now with that specific ID in hand, we will then link now the shapes from tiled to that specific ID so that we can reuse it. So in here, our result will be then mutable map, where the key is a game object, and the result is maybe a list of fixtures. Or is that one fixture still? Or is it a fixture definition? I'm not even 100% sure what we are actually getting. But that is what we want. So for a specific game object ID, we want to have the fixtures that we need. So first of all, let me take off my shirt, please. So, let's check out the code from last time. I think we put it under spawn system, if I remember correctly. And here we created the box2D body. And what is this box actually? It's a fixture definition. It's a fixture definition. That's interesting. So we need then a list of fixture definitions. That is what we want. A list of fixture definitions. So that is our goal, that we get that. It's getting hot in here, Mr. Valvorik. You're still not in the guild in Idle Heroes. Not sure if your level is already high enough that you can join it, but I'm missing you in the guild, which will also empower your heroes endlessly. It's amazing. So, do we need this for each cell stuff? No, we just need the... Why did we do that? Here it makes sense, but now we actually just want to go over the tile set, so we don't want to go through the map actually. So it's a little bit different. So there should be just one tile set. It doesn't make sense if there would be more than one. So let's call it tile sets. Or let's do it like this. So if tiled map tile sets size, length, how did they call that? Hello? Isn't that, what is that? That's it's a map. A map of what? No, not tiled map. I mean tile sets. Tile sets is a tiled map tile sets, and that is an iterable. Doesn't an iterable have a length or size or whatever function? Size, length? No, but it has internally these tile sets again. Can I somehow get them? I just want to add some error handling that if there would be multiple ones, that I print an error or at least a warning that that is not supported, but seems like that's not available. So what we do here is then from tile map tile sets, we get the, or is it then get tile set or get tile sets? How do I get the get tile set? Here it is. Okay. And here we want to get just the first one. And most likely that could be null. So if it is null, then we throw an error. And there is no tile set in the, let's make that in a separate line. There is no tile set in the map asset objects tiled map. Okay. So I actually want to have it like this. It's not pretty nice. Is it the best thing that we can do? It's the best thing that we can do. So at that point, we have the tile set, and now we want to get the tile. Can I somehow get all the tiles? No. How would I know how many tiles there are? We need to debug it. I don't know what kind of information I have here available. So the easiest thing is always to find out what you have when you set a breakpoint and then just debug a little bit the data that is available here. So first of all, we want to add another screen, which is our loading screen. The badge, we don't need it for now. Maybe later on we want to show something nice and fancy in there. But for now, we don't need it. And our first screen is then our loading screen. And here I think it tells me that that could be also a constant, which we will do. And then we come back to our loading screen and start into the debugger. Still no plan to do in Idle Heroes, but I get in-game money for Star Trek timelines, achieving things in Idle Heroes. So this is nice. Okay. So there's some interaction between those two apps. That's cool. So tile set, tell me what kind of information you have. You have a name, you have some properties with a key table which tells me first grid and the value is 53. And no, first grid equals 1. So not sure if that is useful. And there is what is in there? So there's 1 equals to some tiled map. So there would be tiles, and tiles seems to be a map. Can I get access to these tiles? I cannot. Is it private again? Let's go in here. Shit, I pressed the wrong button. Is it F4 or Alt F4? How do you navigate to tiled map tile set? Tiled map tile set. So in here we have tiles, and tiles is a private integer map. And I don't get access to that, which is super sad. What do I have available? I have get properties. I have a get tile, but here I wouldn't know when it's what are the different available keys. There is an iterator to tiles in this tile set. Aha. Then let's get the iterator, I would say. There's also a size in it. It returns the size of this tiled map tile set. Okay, why didn't I see that? Was I simply blind? We have a size that makes it easy. And now we can do this one. And that one we simply call tile ID. And that is perfect because now we can get the tile from that specific ID, and from that tile we can get the objects, and now we can do this parsing again from last time. So now we have everything that we need. Last time we put everything in here. So actually here we get an object, and there we have this logic in here. Since we now also need that in the loading screen, we most likely will extract that and maybe call that. So what do we want to get out of this one? I would say just a single fixture definition, most likely. So for a rectangle map object, we want to get a box. And then just use it. Go crazy. No, and then just use this one in here. I think that should be everything that we need to extract. Yeah. So let's do that. We have already quite some files out there, which I don't like a lot, but let's go with that. How do we call that? Maybe physics utils or box2D utils, something like that. Box2D utils, something like that. And we want to get this code in here, and there a function which we call like fixture definition by map object. So something like this, and you pass in the map object and you get back a fixture definition. What we could also do, since we have Kotlin, and which I actually like more, we could make an extension function, fixture definition of. That is a typical approach that I see from time to time. And we make a fixture definition of a map object. I think that makes even more sense and is better. So in here we get is rectangle map object. Then we return something, and we return currently a box, which is also not perfect. So maybe later on we will replace that with a loop, so with a shade loop, but for now it's a box. Unfortunately, this box is just a LibGDX extension from what I know. And in the background, it's creating what? It's a shape and shape set as box. So this is what we need. So let's just take over that code from here and adapt it. So we have a shape, and this shape, we set it as a box. We have the, we did not destructure the rectangle, that one we also can take over from here, which is actually important. So our width that we passed in for the box was the width times unit scale divided by 2. The height was this one. The position is a vector 2, 0 actually, so we don't want to have any offset. And the angle, we also don't want to have any rotation. So here we already have the box, and finally we want to return a fixture. What is a fixture again? That seems to be a function. Oh my god, which does a lot. Let's also take that over. And what we want to have here is then return a fixture definition. And there we apply certain things. So dispose of shape is true, most likely, because we want to dispose it, I would say. The shape is our shape from before, which I also want to write in a different way. Set as box. That just returns a unit. That's unfortunate. We will beautify that a little bit in a moment. And then we also call an fixture definition init. Where is that function coming from? That seems to be again an extension. Then fixture definitions at what? What do you mean, Schlau? You didn't write anything. You just write Gargoyle-König. There's nothing that I can answer to or respond to. What is this init stuff? Is it again? Okay. So that would be some additional stuff that we could set on the fixture. Maybe something like user data and stuff like that, which we don't need. And then he's actually fixture definitions. Where is that coming from? I don't see it. Most likely per body, he's storing the different definitions and is adding them at the end to the body. So we don't need that as well. So we can simply skip that. We don't need init. We don't need to have all of that. We are already golden. We also don't need the X and Y, so we can skip that here as well. And that one we just called map object. Then the return can also be moved outside. And by default, or is it called else? I think in Kotlin, there we print an error, unsupported. Oh God, what am I typing? Unsupported map object. And then we print out the map object. Okay. What I don't like is this one here. Because then it can be somehow Where do I want to extract it? I want to extract it here, and we call that box width, and that one we call here the box height. Then it's easier to have it in a single line and something like this. Can the polygon shape actually take anything else? No, so we do it like that. I think that looks good. You can at least acknowledge me writing it. Yeah, I did. Have you ever used Composed? No, not yet. I just saw a couple of videos about it, but never used it. Do you have any experience with it? I'm also not sure how usable it really is, because they are promoting a lot of stuff with Kotlin, but I'm not sure if all of the things that they are showing is really production ready, or it's more like a alpha or beta version to get some feedback. Good, so we have here our extension function that should now help us in here. No, first of all, in our spawn system. So we get here the X and Y coordinate. We don't need the width and the height anymore, because here it's a little bit, let me think. What is happening in here with all the, so the init block, that one. So when we call box, what is actually happening? So set as box and return fixture something. And most likely here, so I'm not 100% sure. Body definition init, that is executing the entire code, and then he's calling create. And here, so here he has the fixture definitions. Okay, so I get that. I didn't know that before. So a fixture definition makes sense. It's just the definition of the fixture. It's nothing, it's not really something that is then used in the physics engine. It's just, for example, the definition of your circle or your rectangle or whatever. And with create fixture, you get then a real fixture object out of that definition. And it needs the definition to know how it should look like and how to create it. Which makes sense. And this fixture is then somehow added or not. So where this is my body. Body create fixture. Okay, so this is a call to the physics body, and this adds the fixture to it. What is important, we need to actually dispose it here. Is the fixture definition also something from LibGDX actually? Yes, it's something from LibGDX, which we are using here. That's interesting. So normally, and here it's just called a fixture def. Okay, wait. Then we need something a little bit different. So this is also for me a little bit new, so I don't know everything. I think we just need a fixture def. We want not the KTX extension, which is used internally for the DSL stuff and everything. We want just a normal one, a fixture def. And what does that do? How does that work? Let's also give that back here. It has nothing inside. So dispose of shape, that's not going to happen here. required fixture definition, which is also not correct. I think that's it. It's a lot simpler. It does not have all of that. So we could set here density, friction, if it's a sensor, restitution. So all of that stuff. That's easy. Do we get that in one line? No. No, but that is now really what we want. So the fixture def, it's a little bit confusing. So fixture def is the original one from LibGDX Box2D stuff. Fixture definition is something internally in LibGDX. And now finally to come back to our spawn system and replace that. So what we want to have here, we have the body out there, and our body has a create fixture function. And there we make fixture def of, no, fixture def, not the constructor. Oh, we need, does this need to be public? I'm not sure. No, everything is public. Why don't I have that extension function available? Because it's part of a class and not of the companion object. Can you even write an? Okay, we make it different. We call that fixture definition of, because I cannot remember how you would do that in Kotlin or if that is even possible. So we will do it like that. Fixture definition of, and then we pass in the map object, the collision object, sorry. There's a Valvorik missing. As always, there is a Valvorik missing. Okay, what is the problem now? Expected an element. No. Okay, there was something weird. So all this box stuff, we don't need it, but we need to dispose that now. So this returns a fixture. Do I just directly call dispose here, or? Oh my God, how do I clean up the shape? So again, let's go one last time. We need to check that to use it correctly and don't have any memory leaks. So we have a create function here. There he is creating the fixture, which is good. And if we want to dispose of the shape, then we call fixture definition shape dispose. Aha. Yeah, okay. Then we need to do it in separate steps. So first of all, we get here the fixture definition. Then we create it, and then we can dispose the shape. So that should be the correct way to do it, and seems like we don't need here the rectangle at all. Amazing stuff. Does this still work? Let me see if we destroyed something now or if everything is still good. So let's start with the game screen and let's see if we still have the collision shapes there. No, they are no longer correct. So we broke something. Damn it. What did we do incorrectly? We have a position. Let me return the code once more. No, not like that. We check it in the Git history because we have a Git history. What the hell are we doing? So So here we had the width and height. And we had an offset. Yeah, we have the problem again from last time because it tries to center the box around this position, which we don't want. So we actually really need an offset. Yeah, so we will take over that position. I think that's most likely something in general that we want. I hope. So here we need again our rectangular X and the Y, so the position. And that gives us a box offset. And that is actually what we want here. Now we didn't break anything. And what I just see, so rectangle width times unit scale and half of it, we already have that here. So this is simply the box width and this is simply the box height. Okay, I like it more like this, that you have X and Y as a separate line. It's easier to read for me. So now everything should be back to normal. Yeah, so we fixed that and we used a different code. And hopefully we also are disposing the shapes correctly so we don't have any memory leaks. So that, I think, should be good. So now back to our loading screen actually. So back here we want to switch back to our loading screen. And in our loading screen, so now we are here. We have here the tile. And for every object, there's both like there is a map functionality. That's interesting to me. So that one, we make a fixture definition of that one. So we already get back a list of definitions. And this is actually what we want to store. For now, maybe just in a global map, which is the easiest way to pass it everywhere and to have it available everywhere. And I think that's some game global stuff that we might want to have. So I think it's good to, or easy, the easiest way for now to have it everywhere available. So we call that object fixtures. And that is a mutable map with a game object as a key and a list of fixture definitions. And ideally, it's just a map of something, but we cannot do that because we modify it later on in the loading screen. There would be ways around that, but we don't do it. We make it now very, very simple. So these are our, let's call that object fixture definitions. And then we have our, how did we call it? Object something? How did we call it? Object fixtures. Okay, let's call it like this. And there under, we need the key. Aha. How do we know that this tile belongs to a specific key? So that's not that difficult to solve. I would use here, so we are in the tile set, we are here on this tile, and we could either set a class Should we use the class for it, or we set a custom property? Does the class... Yeah, I know that they switched around the class and the name from time to time, so I think the safe way is to just have a custom property. And that one we call game object, the string, and that one we call here player. Okay, so we need to read that property in our code. So from the tile, we get the property. Yeah, we get the property or null. Let's do it like that. And the key is game object. And if it is null, we again, let's move that a line above. So game object ID. And if it's null, then missing property game object on tile and then tile.id. And finally in here we have the game object ID and the object fixture definitions. Okay, so this is unreachable code. Cannot use nothing as reified. String. Okay. No, it's not. Yeah, this is actually a string. Hello, Christoph. So this is actually a string. And then we want to have something like game object value of. And there we pass in that one. So that's not really the ID, that's the game object string. Let's call it like that. Okay, so in the end, I would expect that we now have, at the end of all of this stuff, let's see, we should have a map with one key, the player, and 3 fixture definitions. No, just one fixture definition. Why? You will see it in a moment. We will never reach this breakpoint here. Think about it. Why? Because we have a null pointer except... Okay, I did not expect that. What I actually expected was, since we have 2 circles and 1 rectangle, and currently our functionality only supports rectangles, we should get this error, so unsupported map object. But we actually got a null pointer. What the hell? How did we get a null pointer? Is tile objects, it does not have objects or what? The tile should have object. The tile is null. Eh? Because I remember now, because there is some information in the tile set which tells us about the first GID. Haha, we need to read that information. Wow. So we develop here some fancy code, but the cool stuff is when we have that available, in theory, we could use that for every game in the future, and we have some awesome integration with the tiled map editor and can use that for our LibGDX games, which would be great. But while Warwick knows it as well, I love to start from scratch also in games. For example, in Diablo 2, I'm the guy who plays 20 characters on normal modes instead of playing 1 character to hell. I am always the guy who likes to start fresh. Okay, that's hopefully easy. So first, git equals to tileset properties gets or null. Why don't I have here a property or null? Sorry, property or null. Then we get here, what is that actually? Is it an integer? It's an integer. So we get here an integer. That makes sense. And the key is first git. And if it's not there, then we have again an error. There are a lot of error cases that can happen here. Tile set blah 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 does not have a first git property. Okay, and then our loop is simply from the first git until the tile set size. Do we then maybe also if the size is 1, so the size is actually 1, so it for sure needs to be include the end of the size. But could it ever be that the first ID is, for example, 50 and we only have 2 tiles? So we would go here from 50 until 2, so it will never go in here. So I'm wondering if maybe we should write it like this. So from until size, but that's not the tile ID. That's really just I. And the tile ID is then simply the first git plus the current counter where we are. So something like that. Maybe that's the safer way to loop over all tiles of a tile set. So let's see. Let's slowly step through that. I totally agree. So tile set, first git is 1. Then we have our loop. We have the tile ID. We hopefully get here a tile. Yes. From that one, now we should get the other error that we don't support circles. Unsupported map object, ellipse map object. So that is the one that I expected, which is a good one. So this error is fine. Ellipse map object. And what does an ellipse have? It has an ellipse shape. Do you say ellipse or ellipsis in English? What is the correct term for that? And that one has an X, a Y, which is most likely again the offset like we had it above. And also a width and a height. Okay. Okay, that's really interesting. And the fixture definition, is there also an ellipse shape? Elliptic curve? Just kidding. So polygon shape. What other shapes are there available? Let's open that package. We have an edge shape, a circle shape. I think that is what we want. But it's not a circle. It's an ellipsis. Does Box2D not support ellipses? That would be disappointing. That would be really disappointing. It has a position. Huh? Download the source. The circle does not even have a radius? That does not make any sense. A circle shape. Returns the position of the shape. Yeah. Hä? And it does not have a radius or what? I'm so tired. If I don't answer anymore, I fell asleep. Have a good sleep, my friend. And I can understand you. Normally, especially on Monday, I'm also super tired all the time. Let's go back to our spawn system. So in here, there are a lot of fancy box2D extensions. Isn't there an ellipsis? No, but there is a circle. And in the circle, I can at least pass in a radius. And this radius, the circle shape does have a radius, but why didn't I see that? Circle shape. Okay, now I'm somewhere else. Where am I now? Haha. So chain shape, circle shape, edge shape, polygon shape. Nah. That's the really unfortunate. It seems like there is no ellipse shape in, at least in LibGDX box2D integration. So we can never create a fixture like that. We could, of course, use a polygon most likely and split that up and do some crazy math with that. But I don't want that. So what we need to do, we need to make that circles somehow. And when I hold shift or something, does it? No. How can I? How can I keep it a circle shape? What did I do now? I deleted now everything. I didn't want to do that. So again, so we have a circle and now with Alt. No, that looks very strange. With Shift. Also not perfect. With Control. Shift and Control, Shift Alt. Not sure. So it seems like we need to take care here ourselves a little bit, that we somehow need to check that it stays like a circle. But that's really, I'm a little bit disappointed that that is not supported. So then it's maybe even easier. So here, let's make it the feet like this. And for the head, we just don't use a separate shape. We keep it as simple and just extend the box. So we will have it like that. Circle here. Here we can check it. So width is also 17, that it has the same width and height. I think that's okay, since the other shape is not supported. Okay, I think that's good enough. So we want to have a circle shape. Let's close everything because I have too much open, and we want to go to our box2D utilities, and in here we want to create now a fixture definition again. And in that case, our shape is a circle shape. Yes. And can we do something here? Because we want to set a radius and a position. Exactly, that is what we want. So we need the apply function here again. We have a little bit of a nesting, unfortunately. Yeah, so the radius is equal to what we get here. So here we most likely also will do some destructuring like we did it above. And we also want to set the position. That's the only thing that we can do. So coming back to our math stuff. What do we have here? So we have map object, and that one returns an ellipse. So in our math here, we need an operator function for the ellipse. Component 1 returns a float, and that's the x. Then the component 2 is the y. And it's actually very, very similar to what we had above. So that's the width and that's the height. Maybe there is even, is there a shape 2D? Shape 2D. Okay, but the shape only has a position. It does not have a width and height all the time. But out of interest, can we simplify that? So that is maybe just shape 2D. No, okay. It just has the functions, I think, for get the position, but it doesn't have a property for that. So we need to duplicate it. Good, then up here, let's destructure now our ellipse. Then we have here x, y, width, and height. Then with the ellipse shape, I'm not so familiar, but the position is most likely again the vector 2. We have the x times the unit scale, and most likely the circle is also centered around the position. So similar to what we had with the box maybe. So we also need to have here, like we have it above. I think it's really actually almost the same code. Let's see, ellipse width and ellipse height. So that would be here width, height. And here we add the ellipse's width, and we have the y times the unit scale plus the ellipse height. So for us, width and height must be the same because we anyway can only set here one radius, and the radius is now whatever we choose. We could make here also a check. So if those values are not equal to each other, we could throw another error because that's not supported as we have seen here. But yeah, let's add that just as a safety reason. Maybe in the future there will be something available for that, but here as a safety reason, we will remove it. So there is, since those are floats and there might be some, it might be not that accurate. I think there is is equal with a tolerance. Exactly. So there we put in ellipse W, ellipse height, and let's say 0.1 tolerance. So if it's not equal like this, then we throw an error. Ellipse shape is not supported. Only circles. Ellipse shape is not supported. That's not really true. Ellipse shape is only supported if the width and height are equal. So something like this. Good. So now we should here correctly parse these shapes. And now we should reach our breakpoint in the loading screen. But we hopefully now get a map with a single key, a player, and it has two shapes. It has a polygon. It has two polygon shapes, yes. But one of them is with a circle and one of them is a box. So that one, that above here seems to be the box. And that one here is the circle, which has a position 0, 0, okay. And the shape, okay, we don't see a lot of information here. But yeah, that that's already part 1. Now what we want to do is, first of all, when that one here is over, we need to switch to our game screen. So for that, we also need access to our game, which is actually, it's just a KTX game. It doesn't have to be. Okay, but I would, yeah, then let's write here Quilly Jumper. It's easier. So in here, we can then remove the screen, the loading screen. It's no longer needed, and the resources can be cleaned up. Also, does that call the dispose method? No, it does not. So what we need to do, we remove the screen. Then I would say we call the dispose function. If there is one, so if we clean up any resources here, and finally we set the next screen, which would be our game screen. So this is how we get back to our game screen, but now before we have now parsed all these different fixtures. And finally, in our spawn system, what are we currently doing? So we go through, currently we just go through all the tile map tile layers. This is for spawning the ground up, so that's the static box2D bodies. But now we also want to iterate over all layers actually. And that one we can call, maybe that one we can call spawn ground entity. Yeah. And again, so we need to modify that code here a little bit so we don't filter. We actually go really over all the layers. And we don't just get here the cell, we also pass in the layer here in the callback as well. I think it was called just tile map tile layer, right? Tile map tile layer. No, that's already the, it's just map layer. Okay, so map layer. Okay, so in our action, we also pass in the layer. And down here, we also get our layer. And now if layer is then we do that. We spawn ground. So this is a tile layer, contains static collision objects, spawn static physics body. And here else object layer contains game objects, spawn, how is it called? I think kinematic or dynamic body, if I remember correctly. Dynamic or kinematic body, whatever we choose. Today we will choose a dynamic body, and that's it. So let's make here a breakpoint just to be sure that we end up at the correct places. And what we need now, we need in our test map here. There we, oh, maybe I did a mistake now, because now we would need access to this tile set here. Ah, that was stupid. What I want to do now would be that I add the tile set from here also to this map, so that when I'm on the object layer here, I can place the game objects correctly. But can I fix that? Can I not embed it in the map? Is that somehow possible? I don't. Most likely you cannot change that afterwards, I could imagine. Haha, wait, what is that? Maybe that's it. Wait, it could be that it's this one. So we have it now extruded, it's called like that. And now, hopefully, I have it here available. Haha! Okay, and which one is it? This one. So here I want to add the player now, which is funnily a little bit too big. So let's make it like this. And our player should, for example, spawn here. Will that work? So we should at least get now to the breakpoint, hopefully, and because we are on the object layer and we should get to the breakpoint at least. Let's see. Oh, there's no get cell on a map layer. It's only available for tiled map tile layers. Yeah, because an object does not have. Okay, then we need to do it differently. So here, let's revert all of that. Unfortunately, because what we did before, or the way we changed it, does not really work. So spawn entities, then let's make it like this. First spawn static ground bodies. And then second one is spawn dynamic kinematic game object bodies. And here we do now the same like we did before. No, the filtering won't work at all. Or is there filter is not instance? No, that's not there. So we have just a filter and it is not tiled map tile layer. And then for each, and that should be our object layer. And hopefully we can stop now at that point. Here also need to pass this as a reference so that we can switch the screen to the game screen. And we stopped here. And is that really our object layer? Yes, it is. And there we have now, yeah, just the object. So from the object layer, we want to get the objects. And for each object, we are now spawn, let's call that game object entity. And there we pass in the map object. So we just need a new function, the map object, which cannot be null. And here we can now I was too early, I think, because we need here the information that it's a player. So we have the object here, but does it have the property game object? Let's see, what kind of information do we have here? So we would need this information that it's a player game object, because we want to get here the fixture definitions and then create the body out of that. So let's see, we have a map object. It has properties which are useless for us, but it has a reference to a tile, and the tile has the game object information. Okay, so the map object should have access to the tile, but I don't have that. Because this one is a tiled map, tile map object. Most likely, it's always a tiled map tile object. Maybe, maybe not. I'm not sure. So we will make a safety call here. So if map object is not a tiled map tile object, then GDX error unsupported map object, and then the map object. And if it is one, then we should now have access to the tile. Perfect. Then we have access to the property, where we already know. Yeah, here we know that it cannot be null because we used that already before during the parsing where we throw an error. So we don't need here a separate check for that. And now we have this one available. And finally, from our object fixtures, we get the game object value of game object string. And maybe one, do we ever want to have things which don't have fixtures? So would we, no, we wouldn't have that. That would be also an error case. So one more thing in our loading screen, just to avoid very, very weird behavior in the future, to be safe, when we have here our object fixture definitions, we check if is empty, then we also throw an error. No collision shapes defined for tile $tile, or just the ID of the tile. Okay, so at that point here, we can be sure there are fixtures available. And what we want now is we want to create a body. So physics world body, this one is now a dynamic body for now, which has a position from our map object. So is map object X times unit scale, and the Y coordinate is the Y position of the map object, and that one we can pass in here as a position for the body. And now for every fixture definition, so these are not the fixtures, this is already bad wording, it's the fixture definitions. And for every one of those, what we want to do is from... so that's actually afterwards, I remember now. So we want to have, first of all, why is here a circle? Let's remove that, that's a mistake. I hope we did no other mistakes. We need to check the Git history today because we added a lot of codes and we had a lot of different tryouts. Things. Okay, so position, we won't want to rotate. Now we want to loop over the fixture definitions. Okay, it says here that it could be in theory null, just to be on the safe side. We have here again no fixture definitions for, and then game object string. Okay, so here we have then the definitions, and finally we want to have body, create fixture, we pass in the fixture definition, and then we dispose the shape. I think this is what we did here below as well. Yes. And the last thing, so to group it a little bit. So here we have some generic stuff. So here's really the spawn physics body. And below we have the spawn entity stuff, where we have again an entity. The user data is the entity. We add the physics component again to it. And now after all of that, so 1.5 hours later, we should hopefully, no, we don't see a player, but we should hopefully see the Box2D shape. I'm so happy. Does that look like in the editor? First of all, why doesn't it fall down? Because we don't step the physics simulation yet. So that's okay. So we don't, if we would update the physics simulation, then the player would drop down to the ground. Currently he's static. Let's see if that is matching tiled. Best way is to make a screenshot, I would say, of that specific area. Oh, I need screenshot, or can I open this now in a tiny little window? I don't see. It does it. Okay, great. So let's zoom in. So we have a circle which is right above this black line here. We have that here as well. Then, I mean, we don't have the graphic yet, but we have the box where here there's a little bit of a triangle thingy, which is also here. And the box goes over it. And we are also... No, we are more to the left, I would say. Way more to the left. If you check it out here, so on the first tile, which would be here, the entire body should be somewhere here. Why is that? I'm late again. I'm missing everything. But you can watch it later on if you want. I think it gets stored on YouTube. Hey, Fatih. Okay, that's interesting. Why is it too much to the right? That is not correct. So the shapes itself, so how it's stacked together, that looks perfectly good, but it's too much to the right. So position should be 6 and 69. Oh, 96, not 69. So let's debug here. Do we get that position? So X is 6 and that one is, oh, that's interesting. It's 64 instead of something else. Ooh. But the X coordinate is our problematic coordinate, and that one is 6, which is correct. So divided by something. Our X is then 0.3. So we set this here as the position. I think maybe the object fixtures here are not 100% correct. Let's see. Are we doing character movement with joins? Looks like it. No, the approach that I wanted to choose for this specific game here is that we created a separate tiled map, which we called objects, and that one has a tile set in it, which is a collection of images. So currently we just have the player image in there, but in the future there will also be then other game objects and enemies in that tile set. And with that, we can use the collision editor of tiled, and then instead of just having a box or very simple shapes that we can easily create via code, we can now use this collision editor to come up with more complex fixtures for our player, or for our objects in general. So like here we have the box and we also have the circle, and those two things belong now to a single player body. And what we did today, so currently we pass this information, we have a loading screen which is loading this objects map and gets all this information out of it. And these fixture definitions, they are stored in a map with a key, which is the game object ID. And today we are just introducing the player, but in the future we are introducing, of course, more objects. What I don't get now is why our shapes are too far to the right. So there's obviously something not 100% correct. But how? I don't have here any information, unfortunately. So I don't see here a position or whatever, because I think there is this, how you call it, this JNDI stuff, so that you have some interaction with C or C++ code. So we need to make a breakpoint earlier here. And here we are, no, actually in here. So here we are creating the shapes and everything. And wait, one more thing that we know. One more thing that we know is that this is actually correct. So it's definitely not a problem with the offset of the box, because if it would be a problem, then the ground shapes here would also not be correct. So I guess it's really a problem then with the position that we get from here. So let's try to understand that. So why is that position here 6? 1, 2, 3, 4, 5, 6. That makes sense. It's 6 pixels to the right. And we scaled it a little bit, right? So that's not the... Wait, let me quickly remove it. So the original object was like... Why can I not draw now? Object, object. Okay, now. So this was the original size. So let's place it, for example, exactly here. That is the easiest one to debug. So we know it's exactly off the edge of, at the end of the first tile. How does that look like when we load it now? So what is the... Okay, no, now it looks good. You see, it's perfect. So it's at the bottom or at the top of this black line here, and also at the beginning of the second tile. So this is now exactly what we have in tiled here. The circle is at the beginning of the second one here, and it's at the top of the black line. So the problem was with the scaling actually, which is interesting. So when I scale that down, does the X and Y move? Yes, they do. But our problem is that we did not consider that properly. So I would say we don't need to support everything for now. So let's be happy. Let's just place the player like that. It's not scaled. So the player is actually quite big. Really big. we need to take care of that. But anyway, at least the creation of the fixture definitions and all of that, that one is working, and that is the important part of what we try to achieve. So I think, let me check. We have the collision editor, spawn player that is placed in tile. So that one we have done. And then integrate box2D for player character. So we have the collision editor and tile, support different tile shapes. Yes, we have rectangle and ellipsis. We have a circle and a rectangle. Polygon, just for testing. No, let's skip it. We don't need that for now. So that one is done. Then a physics system with interpolation. We don't have that yet. And a keyboard input listener. We also have that yet. For sure, I want to add the system at least. And what we are actually also missing is render player graphic. So we need a render component with a sprite and also sprite rendering in render system. I forgot about that, but of course we need that because currently we are just drawing the physics stuff. Not sure if we will cover that one today, but that should be a short one. Maybe that will be part of day 3. Let's see how long it takes for us to make the physics system happen. But before we do that, let's quickly go over the code. And let's not commit that one. That one I want to commit. And let's make a save point where we can always go back. That's always a good idea when you implement it a lot. So that we can go back if we mess something up. So assets is okay. Then this utility, this is completely new. It has a green check mark. I think that one is also good. Then we have game object, which is just an enum. We have the loading screen with the show function, which is parsing the collision shapes and puts it in this global map where we can always access the fixtures. Which is fine as well. Then we have new destructuring stuff for an ellipse, which is fine. Then in our game, we added the loading screen at the beginning. And that's also the first screen. And we also created this mutable map and things like that. The spawn system now spawns the ground objects. And also the game object itself, which is also working. There's too much comments. Okay. So here we have the dispose. We didn't forget about that. Here we also have the dispose. Just out of interest, is a definition also disposable? No. Okay. This is really just some numbers that are stored. There are no system resources involved. And that's it. So what did we do? We add game object collision parsing and spawning. That's the first commit. We don't push yet, but so we have a save point now. Good. So as I said, we need another system because currently we have a game screen. We have a physics world in it, but we don't do anything with it. So all of our physics bodies that we are creating, they don't do anything. And that's the reason why our player currently is flying in the air. So he's not in contact with the ground because our simulation does not get stepped. So what do we need to do? What I normally do is I create a physics system. And that one is an iterating system. It's the first one, I think, that we have. And it has the family, or is it just, I think it's just is there a global function world family? Yeah, it's like this. And it contains all entities which have a physics component. And it has some other things. So the family is that one. And it also has an interval because it's a best practice. Don't ask me why. Actually, I know why. it's a best practice to step your physics system with a fixed amount of time. So you don't want to pass the delta time and have maybe one physics step with 1 second, the next one with half a second, the next one with third of a second. That will give you a very poor result to the simulation itself, and you might get some strange behavior, like, for example, maybe bodies teleporting to very thin walls and things like that. And to avoid that, you want in general to update your physics world with a fixed time step. And there are two values which are normally recommended. I think one is 45 times per second, and the other one would be, I think, 300 times per second. So we want to have here a fixed interval of, I choose that one because it requires less computing power and I never needed more accuracy for my games. So it's totally fine for me to have it like that. And here we need to override a couple of things. I think, first of all, the update function, if I remember correctly. And also in our physics world, there is something which is called auto clear forces, which we don't want. So I will have a sneak peek soon because I implemented that multiple times, but I cannot remember everything from the top of my head. The important thing is that it could be the case that our physics system gets actually called twice or multiple times per frame, because for whatever reason, the computer or mobile phone is lagging, and our world update function here, so when we update our entity world, that one here gets maybe a huge number in it. Let's say, I don't know, 2 seconds. Let's imagine it's 2 seconds. So internally, for that single frame where we have a delta time of 2 seconds, it will call the physics system 2 times, right? Because we have an update interval of 1 divided by 45. So it will call it, I don't know, at least it's multiple times. My math at that time is not that good anymore. So it's at least more than 1 time for a single frame. And in here, we would call now something like, wait, let me also introduce that here. So we have our physics world, which we inject. We have that available somewhere. And in here, we will call now this, I think it's called step function. I don't know the values here. I think time step is 2, velocity iterations 8. The other one is also 8, not sure. I need to look up those numbers. But anyway, when you call the step function, then if this auto clear forces is set to true, then if you apply an impulse or a force, after that one, it's cleared from the body. So it's removed immediately. And we don't want that, because in that scenario where we are actually doing 2 steps in our loop, or multiple steps, then we just want to clear the forces really at the end of the frame. So when all the steps calls are made. Otherwise, you get a little bit of a weird behavior, as mentioned. Is it 6 and 2? I'm actually surprised. Why are there 3 values? I thought it's just 2. but yeah. What we anyway need to do, and most likely in your future you will have that as well. I know I have quite a few repositories on GitHub, especially important ones where I know I did something that works. And so I know that I can look up certain things and just use it in other projects. And in that specific reason, I know that I implemented a physics system just recently where I did already everything correctly. So we will have here a little bit of a sneak peek. So what we want in... I made here a safety stuff. So first of all, that one we copy paste over. I explained it in a moment. So our update method needs to be overwritten. I used here an error. Yeah, okay, so let's also add a logging here. But I like to write the logger in lower letters, lowercase, not big one. Big one also always looks a little bit weird. So first of all, if auto-clear forces is not set to true, then we will set it. Then we make the update call. In here, we will now update the physics system. And at the end of the frame, as mentioned before, we need now to manually clear the forces. This is what you need to do when you have the fixed time step approach. It's called like that with an interpolation. First one is the delta time. That might make sense. Okay, then we need to override the on tick. So on update is basically, in our case, we have a fixed interval. So the flex entity component system already supports that. It now checks whatever delta time gets passed in. And depending on the step rates that we set, in our case, it was 1 divided by 45. It calls now the onTick method as many times as it needs to do. And everything that gets, so this accumulator, if it's not sufficient for one step rate, so the value will be between 0 and step rate value. So it's something in between, like half a frame or third of a frame is maybe left over. And at the end of that, it calls this alpha function, which also comes in handy later on when it comes to rendering. And we want to slowly interpolate the graphic of the player, for example, or of the game objects between two physics steps. So also to give you here an idea, let's imagine we are at step 0 in our physics engine and the player would be here. And at the next step, so step 1 in our physics system, the player would be here. It's rather unrealistic that he moves such a big distance. Normally it will mostly be something like that, so a very small distance. But to make it clear, it could be a bigger gap like that one. Like I mentioned before, maybe there's a huge lag on your phone or computer and you have like 3 seconds of delay. So there will be a lot of physics updates and maybe the player moves in here. Now, from a graphical point of view, it would be quite bad if you have a frame where you see the player here and the next frame it would be bam there. That would be quite bad. What we want to achieve is a smooth rendering so that the player slowly moves up to that position here. And that is where this alpha stuff comes in handy, because if we have exactly one frame, then the alpha value will be 0. And if it's just half or third of a frame, then we can interpolate with the value that we get in between those two positions. And at some point we have a full frame again, so then we will be here. But in between those, so for example, if we update the physics systems, maybe just once a second, we will do that for testing to see this effect. Then later on, then we get this smooth transition with the rendering from simulation point A to simulation point B. And yeah, luckily we have a lot of these things internally in Flex already available. Ashley, if I remember correctly, does not have that. There you would need to implement it yourself. But in Flex, we don't need that. So we have the onTick method, which gets called now with our fixed rate. And there we call this super onTick. So actually for every entity, we do something. And also now here we see the step function from the physics world. And as Fatih mentioned, so the first argument is actually the delta time, which in our case is this fixed value from here. It's also system internally. So if the interval is fixed, then it's just this interval.step value. And otherwise, it would be the delta time that we pass into the world update function. But in our case, we want a fixed rate. So we will always get from the interval the step value. And yeah, those other things, those are how many velocity iterations are done during one physics step, and how many position iterations. So this is more like the accuracy when things are colliding with each other. How many calculation does it do to resolve certain things? And yeah, I think a good value to start with is this velocity 6 and position iterations 2. I think in some of the LibGDX documentations, they recommend those values. Okay, and finally, I just copy and paste now a lot of things. So what we want to do, we can do that now a lot better. First of all, this I think is written in Flex 1.6. Now it's a little bit different. So we have entity physics, and since it is a data class, we can also destructure the body out of it. This is when it comes to interpolation. We don't have that yet, so we will skip that. And also, this is then when we want to apply a force or an impulse and move the body somewhere, then we want to apply it here. Because after this on tick, we make the physics world step, and then we apply the force. Also, why is that done in the physics system itself? Because in some other games, I had, for example, a move system, which is called every frame and which calculates the move speed of the player. And in this move system, I already called that specific line here, so the apply linear impulse. And the problem with that is that the move system, since it's running per frame, it might be called 2 or 3 times before the physics system gets called. Because again, here we have a fixed time step, and the other system might be per frame. So if we call this apply linear impulse maybe 2 or 3 times before we reach the physics system, then the player is actually moving a lot faster than he should be, than he should do. And there in some older projects, I had the problem, for example, with jumping, that randomly the player was jumping super high. And the reason was that I think there it was apply force, most likely what I used for jumping, but not sure. And I applied or called this apply force function 2 or 3 times before I reached the physics world step call. And to avoid that problem, I nowadays just apply the forces and the impulses in the physics system just once before the step stuff gets called. So that's the reason. But for now, we don't need that. And since we don't do any interpolation yet, we also don't do anything here. But here you would see how with Flex 2.0, we can easily get the physics body. So I like the syntax here. So from an entity, I get the physics component. And since physics is a data class, I can also destructure things out of it and use it directly, which makes it very short and convenient to write. Good. And finally, we just need that one here. All the thing below is then when it comes to contact handling, which we don't do today. So we skip all of that. But what we need is now this alpha entity that I mentioned. And currently we don't have an image component. So most likely we also don't do anything here right now. So that would be, as I mentioned before and showed in Paint, here we would now set the position of the sprite to this interpolated position. So the interpolated position would be that one here. So that is the, if I remember correctly, we always have 2 positions. So we have the previous position of the box2D body, and we have the current position of the box2D body. So that would be from the last time we called the world step function, and this is currently, so before we called it again. And any position between here, that would be this interpolated position. So the sprite slowly gets updated until we have another step call to the physics engine. And this is what we do back then in the code here, where we set this interpolation of the image. But anyway, for today, most likely we don't need that. The important part for us currently is just that we call this step function of the physics world. And yeah, could be private, so make it private. And now we just need to add the physics system, and we add it, for example, here after the spawn system, and important before the render system, because we are updating the position of the sprite here. And with that, our player should now, yes, he dropped down. Also, what you see here now, you see now some gray lines instead of these purple lines that we saw before. The reason for that is that there is no force or impulse applied to this specific physics body, and it's now also not falling, so it's colliding with a static body, and it's simply now sleeping. So I think in the last part I mentioned that a little bit with this allow sleep argument in the physics world constructor, and this body is now sleeping, and yeah, so it doesn't consume a lot of resources. And yeah, I think that's already good enough for the physics simulation. So we have that done. And now, as a last thing for today, so the rendering, we will move that to beginning of day 3. I think that should be not a big deal to implement. That should be rather quickly. So the last thing for today is just some debugging or simple functionality that we can move the player now to left and right. And what we can do here is in our game screen, in the render method, for example, there we have a to-do, remove debug controls later on. And in LibGDX, there is something which is called GDX input is key just pressed. And then there is a keys class where we can say, for example, the key A, which means we want to move the player to the left. And if it's the, what did it do? If it's the other key, if it's the key D, then we want to move to the right. So this is the simple thing that we are going to implement today. Days are increasing every day. Yeah, that's true. But yeah, as I mentioned at the beginning, since it's not a full day that we are working on that stuff, it's normally just 2 or 3 hours, which is sometimes not enough time for me to finish everything. Sometimes we might be faster and sometimes we are simply slower, but it's a hobby project. It should be fun. I don't need to work overtime or whatever. I just work as long as I feel comfortable. Good. Also very simple here. We can have a family function here, and we want to get all entities which have good question. Do we want to get all entities now which have a physics body? But then we would apply a force to a ground, which does not make sense. So we will introduce something fancy that we have available that you have never seen before, and we call it how do we call it? Entity tag. Let's call it like that. And there we can extend it with entity tags, if I remember correctly. And there we have, for example, player. That did not work. Why? Let me read the documentation. So what I want to do is that I want to mark our player entity, so tag it with this entity tag, and then just get it out from our entity world very easily. But I forgot how it works, so let me quickly check. Where is this documentation here, the tag? enum class, entity tags by entity. Okay, so that is how it works. So by entity tag off, and now it works. So great. And one more thing in our spawn system. So in here, there we have the physics body. And one special thing maybe if our... Okay, let's also extract this game object ID here. Game object ID. So if our game object ID is equal to the player, then we have an entity tag player attached to it. What is a tag? It's basically a component without any data. So like a simple Boolean flag, an entity has it or not. So true or false. And in the background, what is the difference? But why would you use a tag instead of a component with no data at all? The reason it's a little bit, it's stored in a better way internally in Flex. And I think setting and retrieving it is also a little bit faster than with a component. Not huge, but yeah. And also it's way easier now. So if you also need another tag, like for example, if an entity is visible or if it is invulnerable or whatever, it's as simple as adding here an additional enum value and that's it. So this tag functionality was also proposed by someone in the repository, but this tag functionality is very convenient for such things. So we have now our player, which gets tagged with the player entity tag, and that gives us the possibility that we can get here all entities which have the player tag, and for all of them, what do we do? We get the physics system of physics component, the body, and we apply a force. I don't know which force. So here we want to go to the left. So it should be minus something, maybe 10. I don't know, maybe that's too powerful. And we want to wake it up. This one is not allowed. So it's force X, force Y. And where it should be applied. Okay, so there it should be normally the... Isn't it called world center or something? We do it a little bit differently. So we get here the body. Then we do this one and then body center, world center. Yes. I think it's world center. And the first argument we simply put inside a vector class. Then I think we are golden. Yes. And the same thing here below. Actually, all those lines. And here we go in the other direction. And let me replace that with a when because I prefer the when here. Good. So when we press A, we should go to the left. And when we press B, we should go to the right. Not sure if the force is too big or not. Let's see. But it should be... It should at least work. Okay, it moved a little bit. Seems like 10 is not enough. Let's use 100. A great TV show. Please never watch it. Okay. So now when we press D, we are moving to the right. There's, I think, a little bit of a problem that we will optimize later on. So D is working. A is also working. So player is moving to the left. Yes. So we can spam it multiple times. Then he gets faster and faster. Of course, this is not a good movement. It's pretty garbage. But I told you that at the beginning. So we will fix that next day to make it better. Instead of using a force, we will use an impulse. Which then immediately sets the movement speed of the player to a specific value that we want to calculate. But for today, I think that's good enough. The problem that I wanted to mention is that currently we are using here boxes for the ground, and they could be problematic because, again, with inaccuracy of floating point numbers in the computer, sometime there might be a calculation that it thinks there is a little bit of a stair or a step between two objects, and the body then here would be stuck at that specific thing here. And that's called, I think, a ghost vertex, if I remember correctly. And the way I normally solve it is that I simply replace the boxes with a loop. A loop is a chain shape, and the chain shape, for whatever reason, does not have this ghost vertex problem. It's always working. Maybe because it's a little bit elastic, like a real chain in the real world, but I don't know. I just know that when you replace the box with a loop, then we don't have this problem. And we should not forget about that. So after all of that, replace boxes with chain shapes loop. That's an easy one. So that's maybe, I don't know, 10 minutes of work or something like that. That should be easy. Good, but we also have today the input listener, and we are done with that one. What time do we have? It's too late. I don't want to start with the rendering. I think I could actually achieve it within maybe 20 minutes, half an hour, but it requires some setup again, that we correctly load the graphics and things like that. So maybe it takes more time, and I'm already a little bit tired. So I want to stop it at that point. But yeah, I think we achieved quite something today. So it was a little bit complex for sure. We could have achieved what we did here a lot easier, but what we have is that what I really like is that we can now have, when we have any other object in our game, we can simply add that as a graphic to our tile set here. Then we can give it an arbitrary shape. Could be just a box, could be also a combination like we have it here with the player. And yeah, we don't need to write any code for that. We can just use Tiled as our game editor for that, which is really cool. So that one I like a lot. I was a little bit disappointed that we don't have an ellipse shape in LibGDX, so that we really just have circles. It seems like. I'm pretty sure, or I think I know it, you can, of course, make a polygon and, for example, split an ellipse in, I don't know, 300 subsegments and make then a polygon out of it. So you get almost an ellipse, but not very perfectly. So what I mean with that is, let's draw that one. So instead of having that one, we could, of course, make a polygon. Let me zoom in, and let's make it green. So we could have then, if we would have like 300 segments, one would be this one, then the next one would be this one, then the next one would be this one. So we have different tiny little segments and would somehow achieve then this result. But I don't know how you would simply do that. Maybe it's quite simple to actually split up an ellipse into a polygon and create a shape out of it. But I'm not a math expert, so I know what I want to do, but I wouldn't know how to do that now. So that's a little bit unfortunate. So we can really just use normal circles, but I think for this tiny little game, it's good enough. And yeah, we also have some tiny little movement in our game. So currently it's really stupid with just some force pushing left and right, but at least it's something. So we see that a movement would also work. And yeah, the next stream will be already tomorrow because I'm currently quite motivated to work on this little game. So tomorrow will be already day 3. The stream will also be earlier because I only work until around lunchtime, so 12, but I need to do some private stuff. So the stream will most likely start at 3 or 4 in the afternoon. And I'm confident that we most likely cover everything. So if we make a little bit of a longer stream tomorrow, so maybe from 4 until 9 in the evening or something, or 8, so 4 hours or 5 instead of just 2 and 3, then I think we should be able to get all of that going. I hope. Let's see. Goody good. But I'm happy for today. Thanks for watching. I wish you a nice evening. The code gets pushed again to GitHub that you have everything available. Add basic physics, simulation steps, and movement via force. So I will push all of that now. If anybody is cloning that repository and playing around as well, so you have it available. And yeah, tomorrow we make the movement a little bit nicer and also get the player rendering working. Good. Then I wish you a nice evening and a good start tomorrow in the next day. Bye-bye.